Okay, so in this example, we have globally, the long-term proportion of newborns who are male is 51.46%. A researcher believes that the proportion of boys at birth changes under severe economic conditions. To test this belief, randomly selected birth records of 5,000 babies born during a period of economic recession were examined. It was found in the sample that 52.55% of the newborns were boys. Determine whether there is sufficient evidence at the 10% level of significance to support the researcher's belief. Now, first, we need to make sure this is a large sample so that we can use our z-score calculations. All right, so if we put in the 52.55% as a decimal into our little formula, 0.5255 minus 3 times the square root of 0.25255 times 1 minus 0.5255 divided by 5,000, and of course the plus version of that, we get values that are between 0 and 1, as they should be in order to use our z-score calculations. Okay, so let's now list our hypotheses. So the null hypothesis is that our proportion is the 0.5146 that has generally been the long-term proportion for newborns who are male. All right. And then our alternate is that it's something other than that. We're testing the belief that it changes, and it doesn't really say in what direction it changes. So we're going to say that the proportion is not equal to 0.5146. And let me find my not equal symbol. Word seems to be stuck here. There we go. Okay, so we've got our two hypotheses. All right, now let's notice that this is two-tailed since our alternate is not equal to, which means we want to take alpha, which is 0.10, and we want to divide it in 2. All right, so alpha divided by 2 is 0.05. So when we go to our table, we are going to look up 0.05 to get the proper z value that we use for our critical value. So 0.05, let's go to StatTrek again. There we go, StatTrek. And I'm going to put 0.05 in there. And I need to erase what I've got here, but I have a feeling it's going to give me negative 1.645 anyway, which it does. All right, so let's go back. So our critical value, and I'm just going to write critical value, see, is negative 1.645. All right, now let's calculate our test statistic and see if it is to the left of negative 1.645, and honestly, we also have to consider the right 1.645, since this is a two-tailed test. If it's to the right of 1.645, either of those two possibilities will cause us to reject the null hypothesis. So let's calculate our test statistic. All right, so we're going to have p hat, which for us was 0.5255. Oops, let me put some parentheses here. Minus the null, 0.5146, divided by the square root of our null hypothesis value. So I'm going to do square root. P0 is 0.5146. And then if we find the Q for that, 1 minus 0.5146 ends up being, let's see, got it here somewhere, 0.4854. And we want to divide that by the number of babies we had in this sample, 5,000. And when we put this thing into our calculator, the top is going to give us 0.0109, and the bottom is going to give us 0.007068, and that comes out to 1.4 1.542. Now, remember I said up here that if it's to the left of negative 1.645 in the left tail, or if it's to the right of 1.645 in the right tail, we reject the null. But in this case, 1.542 is not to the right of 1.645. And so we are going to fail to reject the null hypothesis. All right, so there is not enough evidence. There's not sufficient evidence to reject the null hypothesis. It appears that economic conditions do not affect the proportion of male newborns.